Very good afternoon, guys. So in previous class, we started discussing about when a body is projected vertically upwards from certain height. When a body is projected vertically upwards from certain height. That height is nothing but it might be top of the tower, or it might be the top of the hill or top of the building, whatnot. If you project a body vertically upwards from certain height with a velocity u, if it takes a time of t seconds to reach the ground, then in previous class we got the beautiful expression h is equal to minus ut plus half gt square. H is equal to minus ut plus half gt square. This formula we derived yesterday. That is in previous class, I mean to say. Okay. So here we considered, if you consider the direction below the point of projection negative, we considered. Above the point of projection we considered positive. These are all we discussed in previous class. Here the same formulas, for example, when you project a body vertically downwards from certain height with a velocity u. When you project a body vertically downwards from certain height with a velocity u, then what are the formulas we used to find h? We got the formula ut plus half gt square. Here is also we got the same formula, but only one difference here is initial velocity we are considering as a negative. Similarly, if I go with to find out the formula v is equal to u plus gt to find out the final velocity after certain time, in this case the same formula we can make use, v is equal to minus u plus gt. So what are the formulas we will use when a body is projected vertically downwards from certain height? All those formulas we can make use here also by considering the initial velocity as a negative. So here one more formula, v square minus u square is equal to 2gh. So the same formula we can use here is also, but whereas initial velocity to be considered as a negative. So that is v square minus u whole square is equal to 2gh. So v square minus u square is equal to 2gh. Same, because minus u whole square is equal to like this. So here what I mean is, whatever the formulas we used when a body is projected vertically downwards, the same formulas we can make use, here also. Whereas instead of u there, here we have to consider minus u. Ashte. Where we are going to apply this? Where we are going to apply these formulas? Especially this is the important formula. Where we are going to apply is, when a body is projected vertically upwards from certain height, Now, the same formulas we can use. For example, a body, in fact, a vehicle andre, it might be a helicopter, or it might be an aeroplane, or it might be a parachute, or it might be a balloon, whatnot. For example, I am considering one aeroplane. that aeroplane, so you just imagine this is one aeroplane, that aeroplane. Initially that aeroplane is at rest. It is not moving. It is an ideal condition. It is at state rest. Now if I drop a body, like this, then that is I am dropping a body from an aeroplane which is at rest, from certain height. I am dropping like this. I am dropping a body from the aeroplane. Now the behavior of the body will be same as that of a freely falling body. You know what is a freely falling body? When a body is dropped from certain height. So there is no question. Here we have to consider u is equal to 0. We have to consider a is equal to plus g, and as usual we'll solve by taking h is equal to half gt square and all those formulas. Here my question is, my concept here is, I am considering an aeroplane, but that aeroplane is not at rest now. That aeroplane is moving upwards with a velocity u. That aeroplane is moving upwards with some velocity u. From that aeroplane, I dropped a body. So the aeroplane is moving like this, or helicopter is moving like this, or parachute is moving like this, with a constant velocity, it is going like this. From there, I drop a body now. So will here, this body will behave like a freely falling body or not? That question arises. In previous case, what I said, a body is dropped from an aeroplane which is at rest. In this case, I said that this body behaves like a freely falling body. The nature of the body is a freely falling body. But here, the aeroplane is not at rest. It is rising. It is going up with a uniform velocity u. From there, I drop a body. Now, this will also behave like a freely falling body. That question arises. But actually, this body will not behave like a freely falling body. This body initially will go like this, then after it falls. Andre, once you drop your body, this is an aeroplane or helicopter, it is going up. From here I dropped a body. Then what will happen? It will go like this and comes back. It will go like this and comes back. Which one? Body. Why it is going up initially? That question arises. Because we are dropping the body. Once if you drop the body, because of the gravity, it has to behave like a freely falling only. But whereas in this case, it is not happening. It is rising to certain height, then after coming back. Why? That is because of the property of an inertia. You know what is an inertia? Inertia is nothing but, it is an internal or intrinsic property of a body due to which it cannot change its state by itself. Andre, body rationalidre rationalle irtadu. The body motionalidre, that to uniform motion, it will be continues to be in uniform motion. So you might know that whenever you suddenly get down from a bus which is moving, iga moving bus inda you get down agidrappa, you just get down from the bus which is moving. Then once you get down the bus like this, you will not be at rest. What you will do? You will also run along with the bus. Is it right or not? You will also run along with the bus. That is nothing but my body is having a property called as an inertia. Because of the inertia, my body is still in a tendency to move along with the bus. So here is also same. Before dropping, this body is tendency to move in this direction. Because aeroplane is moving in this direction, this body will also tendency to move in this direction. So once we drop, suddenly this body will move in the same direction as that of an aeroplane. After raising certain height, what happens? Now the gravity will act on it. Because of the gravity, it will falls down. If you see the diagram, this diagram, I can say that it is very similar to the case when a body is projected vertically upwards from certain height. Is it right? So what are the formulas we'll use here? The same formulas we have to use in this case also. Whenever a body is dropped from an raising aeroplane, okay? Put a note, a note down, note. This case is very similar to, note, this case is very similar to when a body is dropped, when a body is dropped from a rising aeroplane or balloon or parachute. Rising aeroplane or balloon or parachute. Okay, if you want, you note down this diagram. This body will acquire, listen boys, listen guys, this body will acquire the same velocity as that of an aeroplane initially. This body which is dropped from an aeroplane will acquire the same velocity as that of an aeroplane. So initial velocity of projection of this body is same as that of the velocity of an aeroplane. Because before dropping, this body is inside an aeroplane only. So with what velocity the aeroplane is moving, with the same velocity this body is also moving. That's why the initial velocity of a body is the same as that of the velocity of an aeroplane. You draw this diagram, you note down those formulas. Okay, based on this concept, we'll solve a few problems today. Note down. A ball thrown a ball thrown vertically upwards, a ball thrown vertically upwards with a speed of 19.6 meters per second from the top of a tower returns to the earth, returns to the earth in 6 seconds, returns to the earth in 6 seconds. Find the height of the tower. Find the height of the tower. So here a body is projected with a velocity of 19.6 meters per second from the top of a tower. It reaches the ground in 6 in 6 seconds. It reaches the ground in 6 seconds. Then what is the height of a tower? H is equal to how much? This was the problem. A body is projected upwards from the top of a tower with a velocity 19.6 meters per second. It reaches the ground in 6 seconds. Then what is the height of the tower? This was the problem. Now we have to go substitute the values. H is equal to minus ut plus half gt square. Whenever you project a body from certain height, this is the formula to find out the height of a tower. Already we derived. H is equal to minus ut plus half gt square, where u is equal to 19.6, t is equal to 6, plus half, g value is 9.8, t value is 6 square. 6 square, see here how to simplify, easiest manner. Here 19.6 is there, here 9.8 is there. So 9.8 to 19.6, okay. 36 divide by 2, 18 will have. 18 I will write 2 into 9. 2 into 9 here I will write. So if I take a common of 19.6, then here we'll have a minus 6 and here we'll have a plus 9. Correct na? So minus 19.6 into 6, because in PUC no problem, you can use calculator, whereas in objective we cannot use the calculator. So that's why we have to simplify it in the easiest manner. This I will write 9.8, 36 ra, 36 by 2, 18. 18 I will write 2 into 9. Okay. Now 9.8 into 2, 19.6. So I will take a common of 19.6. Then here we'll have a minus 6. Here we'll have a plus 9. Like that you have to simplify in the easiest way. Instead of multiplying 19.6 into 6, instead of multiplying 9.8 into 18. So if you do like this, only one multiplication, that's all. So 19.6 into 3, minus 6 plus 9, 3. 6 3s are 18, 18, 9 3s are 27, 28, 58.8 meter. So spontaneously you should get an idea to while simplifying. That is very, very important. By saying itself you have to get 19.6. Okay, there 9.8 is there. 9.82s are 19.6. So we can take a common of 19.6. Like that you have to think. Then the simplification will be easy. Next one. A ball is thrown. A ball is thrown vertically upwards. Vertically upwards with a velocity of 20 with a velocity of 20 meters per second, 20 meters per second from the top of a building, full stop. The height of the point, top of a building, full stop. The height of a point from where the ball is thrown, is 25 meters, from the ground, full stop. How high the ball will raise? How high the ball will raise? Question mark. Continuation. How long, L-O-N-G, how long will it be before the ball hits the ground? Before the ball hits the ground. Before the ball hits the ground. This was the problem. Here is given a ball is thrown vertically upwards from a building with a velocity 20 meters per second. 20 meters per second. The point from where the ball is projected is at a height of 25 meter. Then first thing he is asking, how high will it raise? Second thing he is asking, how long it will take to reach the ground. How long is nothing but the time, how much time anta. So if it takes a time of t. So two things he is asking. First one is how high will it raise? Second one is how long will it take? How high will it raise? This much of high it will raise, called as the maximum height. So the formula to find out the maximum height, H max is equal to U square by 2G. U square by 2G. Okay. Where U is equal to 20 divided by 2, G value 9.8. But until and unless he mentioned the G value as a 10, we cannot take the G value as a 10. You have to take G value as a 9.8. But here what I am doing is 20 is divisible by 10. That's why to make simplifications easy, I am taking the G value as a 10 here. Okay. So then how much it will be? 20, 20 get cancels. 20 meters will be the, how high will it raise? How high will it raise? ಅದೇ listen once. ಅದೇ objective ನಲ್ಲಿ. So he will give the options. But what I am saying, until and unless he mentioned the G value as a 10, we should not take the G value as a 10. So G value we should take 9.8. If you take 9.8, the answer will be just greater than 20. Is it right or not? ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನಾನು ಐ ಆಮ್ ಟೇಕಿಂಗ್ ದ ಲೆಸ್ಸರ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ 10 ಅಂದರೆ 9.8 ತಗೊಂತ ಇದ್ದೀನಿ ಇಲ್ಲಿ. ಆ್ಯಕ್ಚುಲ್ 9.8 ತಗೋಬೇಕು. ಸೊ 9.8 is the lesser than 10. So denominator is lesser here. If denominator is lesser, the answer will be more. So the answer will be just 20 point something will get. Okay. So there, because of 4 options are there, only one option will be there which is nearer to just greater than 20. We can opt that answer. Okay na? Okay na? Yeah. Next thing is, how much time will it take? He given the u value, is given h value, he is asking us to find the t value. Then obviously, the one beautiful formula we have, h is equal to minus ut plus half gt square. H is equal to 25. U is equal to 20. T we don't know. So minus 20t plus G value as a 10. Okay. 10 by 2. 5. 5t square. This I will write with your permission. T square minus 4t plus 5 is equal to 0. Then you go with the factors. So minus 5 plus 1 is the factors. Okay na? By multiplying we should get like this. Is it right? T square minus 4t plus 5. If you multiply 5 we should get. By this 4 we should get. So minus 5 like this. So the answer will be t square minus 5t. Here we'll get minus ra. Plus t minus 5 is equal to 0. Here 25 if you goes this side minus 25 it will be. Then t plus 1 t minus 5 is equal to 0 if you further take factors. So the time will be, time is equal to minus 1 or plus 5. T value is minus 1 or plus 5. How much time will it take? As we know, the time will never be a negative. Time negative iralla. Idre 0, otherwise more than 0 ashte. Lesser than 0 time yavaganu iralla. So this is wrong. So the final answer is t is equal to 5 seconds. Next problem. A balloon is ascending at the rate of is ascending at the rate of 9.8 meters per second, 9.8 meters per second at a height of 39.2 meters, at a height of 39.2 meters above the ground, when the food packet, when the food, FOOD, food packet is dropped from the balloon, full stop. After how much time, and with what velocity, does it reaches the ground? Now what is given is, instead of this tower and all, he says that a balloon. This is one balloon, it seems. This balloon is moving upwards with a velocity of 9.8 meters per second. 9.8 meters per second. When the balloon is at a height of 39.2 meters from the ground, when the balloon is at a height of 39.2 meters from the ground, a body is dropped. As we know, once a body is dropped from any raising vehicle, definitely this body will raises to certain height, then it reaches the ground like this. This body will acquire the same velocity as that of balloon. So he is asking how much time this body will take to reach the ground, first thing. Then as usual we will apply h is equal to minus ut plus half gt square, because this case is very similar to when a body is projected vertically upwards from certain height, where the h is equal to 39.2, u is equal to 9.8 plus g value is also 9.8, 9.8 by 2, 4.9 t square. By seeing this, we can say that every term is divisible by 4.9. Here 9 aiti, here 2 aiti. So 9 sevens. 9 sevens are how many times ra? 8 times. 9 eights are 72, 8 times. Okay, 8 is equal to 4.9, 8 times, okay, minus 2t plus t square. 9 eights are 72, 9 fours are 36, 9 eights are 32, yeah, okay. Now t square minus 2t minus 8 is equal to 0. T square minus 4t plus 2t minus 8 is equal to 0. Factors. So if you take a common of t, t minus 4, if I take a plus 2, t minus 4 is equal to 0. So t minus 4 into t plus 2 is equal to 0. Then t is equal to minus 2 or plus 4. As we know, the time will never be a negative. T is equal to 4 seconds. Like that, we'll get the time. And he is also asking with what velocity it hits the ground. What I said, to find out the final velocity, v is equal to minus u plus gt, where u is equal to 9.8 plus 4 into 9.8, which is equal to 9.8 into 3. So 8 3s are 24, 29. So it hits the ground with a velocity of 29.4 meters per second. Okay, thank you.